We're now going to talk about one of the most important intermediate operations called map, and a variant of it called mapToInt. And these are both intermediate operations. They apply to both sequential and parallel streams. And as I mentioned before, being a good sequential streams programmer makes you a better parallel streams programmer because it's very simple to go from sequential to parallel streams. And we'll use our SimpleSearchStream program as a running example here to illustrate map. So recall that intermediate operations are lazy. They don't actually do anything at all until the terminal operation is reached. And when we get to the part of the course soon, probably not today, but probably on Wednesday, where we talk about the internals of streams, you'll get to find out exactly how this does indeed work. So we'll talk about map and mapToInt. These are both stateless, run to completion operations. Unless, of course, an exception is terminated. It terminates the thing, but let's ignore that. So the way that map works is it is passed a behavior, which is a mapper function, and we'll see that in a second. And this mapper function is applied to every element of the input stream, and it returns an output stream that consists of the results of that mapping. And one thing to remember, very, very, very important, and remember this for your programming assignment, the number of output stream elements that is produced by map must match the number of input stream elements that come into map. So there's always a one-to-one mapping from input stream elements to output stream elements, unless an exception is thrown, but let's ignore that. You can also have a situation where a short circuit terminal operation will cause the map operation to only process a subset of the input stream. So for example, let's say you had an input stream of 5,000 integers, and you were doing map, which was going to, I don't know, check to see whether or not those were prime numbers or whatever. Normally, for every input integer, it would compute whether it was prime or not and produce an output. But if the terminal operation was find first, it would stop after it hit the first one. So just making you aware that the terminal operation will also influence, or can also influence, the way in which the intermediate operations are processed. But barring that, if you have a non-short circuiting terminal operation like collect or reduce or whatnot, then they'll always run to completion, and it'll be a one-to-one mapping for each of those things. And this whole caveat about terminal operations having an influence over whether all the elements are processed, that applies for all the run to completion intermediate operations. So I'm using map as an example and find first as an example, but it's true for any of those things. So let's take a look at how map is applied in the context of our SimpleSearchStream program. So here, as you can see, we've taken our list of search words and we've turned it into a stream of search words, and then we apply map, and for each of the words, map is going to create a search result that'll indicate where that word appears, or where that word appears with a plural, there's more than one match, in the input stream. And that is changing the type. So you can see that map may transform the type of the elements it processes, like a caterpillar going to a butterfly, right? It's changing from one type of thing into another. Here's a little code snippet that illustrates this map method in context. And you can see we say words define.stream, .map, .filter, .collect. Notice the fluent programming style here. So the output of stream is connected to the input of map. The output of map is connected to the input of filter. The output of filter is connected to the input of collect. That's what's called fluent programming. It's the fluent programming pattern. So that's map. Very, very, very common method. There's a slight variant of map called mapToInt, and this returns a so-called IntStream that consists of the results of applying the given mapper function to all the elements of the input stream. And the main difference is that an IntStream is a specialization of stream for the built-in int primitive. So remember, Java's kind of got this wacky distinction between primitive types like int and char with a lowercase c, and double with a lowercase d, and long with a lowercase l, right? So you've got int, long, double, char, float, things like that, all the lowercase stuff. Those are primitive types. And they're done that way because that's how they're implemented efficiently with the underlying hardware. Like your underlying processor set knows how to work on, 1 byte, 2 bytes, 4 bytes, 8 bytes, and so on and so forth to do arithmetic operations. Then there's also an equivalent set of so-called reference types, like integer with a capital I, and long with a capital L, and double with a capital D, and character with a capital C, and so on and so forth. And those are objects as opposed to primitive types. And for a variety of reasons, Java kind of treats those two things separately, which is really sort of annoying at times. Other languages like C++, in my humble opinion, do a better job of blurring the distinction between primitive types and user-defined types or reference types. But be that as it may, that's the way Java works. So IntStream is a specialization of stream for the int primitive to avoid auto-boxing overhead. Don't worry about that. If you don't understand what auto-boxing overhead is, it doesn't matter for the discussions we're doing. As with mapToInt will also must have the same number of elements in the output stream as in the input stream unless an exception occurs, but we ignore that for the time being. So here's how we can use mapToInt. Imagine that we have a list that's a list of search result objects or result objects, where a result object is going to be an object that keeps track of the index where a particular match occurred. And we might have a list of such result objects. What we can do is we can convert that into a stream of result objects, and then we can use mapToInt to convert that to a stream of integers. So notice we have an IntStream. So IntStream actually isn't a parameterized type, but I'm making it look like it is. It's an IntStream that's parameterized by int. And then what we can do there is we can take that stream of ints, and then we can apply an operation like max on it. And what max does, as you might expect, is it looks in the stream of ints and it finds the max value. So this allows us to find the largest index in the results list as an int. And because of the fact that we might not actually have a stream with any elements in it whatsoever, in this case we do, but in general we might not, max might be working on an empty stream, in which case what would it return? Well, what it returns is something called an optional. And we'll talk about that in a second when we look at the code example. So the optional that it returns is something that we can then use with this other cool method called or else. And or else says, if the optional is not empty, return its value. Or else, return whatever we pass here, which in this case is 0. So what that is saying is, if there's nothing in this list, just return 0. Remember that because you'll need that for assignment 1A at the end of the perform crawl operation. Because find first also returns an optional. And so the or else is needed. In cases like this, it's never going to be empty, but you need to have it there for syntactic reasons. So notice how, again, we can convert from our stream of results to our int stream. So the elements can be, the types of the elements can be transformed. And again, notice the fluent programming style. So this is what the code looks like. Here's the compute max method. We take a list of search results.result objects. We convert that results list into a stream of search results.result objects. We apply mapToInt using this method reference to get a stream of int primitives, which correspond to the indices where the results were found. Then we find the max, and we will find it because we don't have an empty list. But if we had an empty list, max would return an empty optional, in which case or else would return 0. So that's the end of the overview of map and mapToInt. Very important methods to understand. You'll need to understand both of those methods in your assignment. In particular, for the part of your program, I think it's the crawl page method, if I'm not mistaken. Crawl page is going to need to take all the elements on a page, be they either links, like a link to some other page, or images, because that's what get page elements returns. It gives you back basically a list of these things, which you turn into a stream of these things. So you'll have a stream of either either images or you'll have a stream of links, and then you're going to use mapToInt in order to recursively either traverse the link or count the number of images, both of which return counts. And so we want mapToInt to return a count, and then you will sum that count at the end of that method. So that's basically the way that perform crawl is going to work. You're going to sum it up when you're done.